This is one. They could both be or one is down. Or both are up. So that's one option.
Looking good. What about all that? Yeah. Okay, because I have another too. It's tricky. They get to be a lot. Like, it gets a lot quick.
So yeah, right now it's down, up, down.
You're on the right track.
Nice one.
Can you kind of out of the room? What would you imagine?
What's up?
No. I put it, it's in like a wall, right? The death, go to the death first, and one switch. And if I came into the lock, is that a really good save? No. Right? Now what if I put two switches? And I set it so this will only open the first one is down and the second one's up. I just picked right. You know what I mean? Would that do a good job keeping people out? It wouldn't take me this long. Because if they came up and like, no, it's not open. First they could like put them both down, so that didn't open. Then they could put them both up, so that didn't open. Well, put the first one out there, so I was down. Both that way. But say it didn't, then I could try one back down, you know? And those are the only combinations, right? Does that make sense? So a lock that can only be locked in 4 ways, is that a very good safety mechanism? Wouldn't make a very good password. If you had a two-digit password and the letters could only be A or B, not going to be a very strong password, right? So now, what if instead of 2 switches, there were 3 switches? Now what are the combinations? What's the first combination I can do with 3 switches? The capability for that. Here I start by saying they're both down. And here I start by saying all 3 of them are down. Does that make sense? Okay, and then maybe we say, okay, I'm just going to change one down, you know? And then down, so those are all possible combinations. Right?
I like the order.
Up, down, right? Up, down, up.
Up, down.
Right? And then we can say, okay, up, down.
Yeah, so you might want another sheet of paper if you don't have room to write all of your ups and downs.
Does that make sense?
Someone asked how Mac was today because it has ups and downs.
Is that all the combinations? Right? How do we combine all this? All of them.
You kind of see which one is which one is.
And we'll just stop there and give it that. How many is it? No, that's okay. See if you can pick them.
Yeah.
Oh, you found lots. I don't know, because can I come here? I think. You come on here. I don't know. You don't have down. And then.
Yeah, 13.
It's tricky. But I'll give you, can you guess? Because 2 goes to 4, 4 goes to 8. What do you think? up to 2, and this one up to 4. So don't think, yeah, I think you're right. So it's going to be 16. Oh, you did. Yeah, that is your point. Let me start to say, I'm very sorry about that. I think folks so after the final, you guys look on the very sorry. How's this going? That's good. I think you got most of them. I love that. I love that. This one I think you're missing fewer. That's perfect. Yeah, that's right. Technically, that's not. All right, guys, I'm going to take your attention up here at least to get you started. Which, if we have 3 switches, 1, 2, 3 switches, what would you start with? What's a good way to try to get all these combinations without missing any? Yeah.
Up, and then.
Okay, so you'd start with up. And then, can I tell you what my thinking would be? My thought would be to say, okay, can I find all of the cases where that starts with up? You know? So we have up, then we could have up, down. We could have up,
Crux of it, how many had a plan?
down, up.
They didn't just come up with random ones. How many had like a systematic method to make sure you don't miss one?
Yeah.
Because it's easy to lose track with 3 things, right?
So can I tell you, this I think is a great strategy, because if you did all of these with that as up, now I could do those 4 again, but instead of making the first one go up, I could make the first one go down. And so I could have down, up, down, up, down, down, up, and down, down. And I think that should be all of them. So it doesn't matter what your strategy is. I saw a bunch of different strategies, and I saw some of them really good, but it definitely helps to kind of organize your thinking. Because already, that's a lot of combinations, isn't it? How many combinations is that? No, it's not 1,000. 1, 2, 3, 4, 5, 6, 7, 8. Now, I'll say this. Is that going to keep like a bank robber out? Probably not. But would that maybe keep like a little kid out if you're just worried about them getting into your stuff?
Yeah.
I think that'd be pretty effective, don't you? If only one of those worked.
Maybe this safe would self-explode if they tried 2 wrong combinations. Inside is safe and explode.
Yeah, the kid is safe. The kid is safe. That's what we do with our candy jar. We pack our candy jar half candy, half high explosives, and the kids know. It's a risk. You want to get candy? All right, try. But you might explode. Okay. You know, I saw a few people. Can I tell you something I really liked? I saw one group that before they even started looking at this, they looked at this and they said 2 became 4, 4 became 8. And they were kind of guessing what they thought this number was going to be before they even started looking at combos. I thought that was pretty clever.
I had a lot of people that assumed it would go 2, 4, 6, 8.
Yeah, I saw that too.
How many kind of thought that at first and maybe were confident a little bit early? And then surprised when I pointed the 7th one that they missed?
Because Mr. Calvert, can I see, and I'm not going to single anyone out here, but I saw the most amazing solution to this somebody had. I thought this was so clever. They said these 8 that I just found, so if I copied that, and I pasted it here, now, when I go to do the next set, well, I'm just putting another switch on, right? So if I put another switch on, I could do those 8 and set the first switch as up. Or I could do those same 8, but set the switch as down. And how clever was that? I never would have thought of that as a way to solve this problem. But isn't that a great way to get the next row? If you've done a good job getting this one, just saying, great, now with another switch, it'll either be this first switch is all up, or we could look at if the first switch was all down. So I saw some great strategies out there. By the way, what does this lead us to if we've got this many? 16. Very good. Hey, does anyone want to take a stab at what this trend is? What's the trend? Yeah, and when we say doubling, in math, how do we double something? What's the operation that doubles something? Multiplying by? Very good. So the trend is that every time we go to a next step, we double. We multiply our options, which if you think about it, makes sense, because every time we add a new switch, how many choices does that new switch give us? It's either going to be up or down. So you have 2 times as many options. All the options you had before, but then you get to do all those with the new switch up, or all of those with the new switch down. You double your choices. So that was really good. Hey, let me ask you, if I had made this chart keep going and said, show me all of the possible combinations if we had 10 switches, could you do that practically?
No.
That'd be a lot of work, wouldn't it? So here's what I'd like you to do. And I want you to see if you can answer this question. I'm going to give you, what do you think, 3 minutes? I think 3 minutes is a good amount of time. The question is, what if I had 10 switches on my door? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I had 10 switches on my door, how many possible combinations could I get? It's a very good-looking door. I don't know if you know this about me. I'm a very good artist.
Yes.
I'm just so happy to have my pen back.
I'm gonna hire you to make my album art.
I flew this morning just using the TSBN teacher laptop, and I found it very challenging.
Oh, it's terrible.
Yeah, it really is not nice. So anyway. All right, team. I want to know, if I had 10 switches on my door, how many different combinations could I set? Get to it. I have complete faith in you. Of course you are. Oh, I'm too slow. Oh, sure. Yeah. I'll tell them that you said, tell Rush I hate his guts and I refuse to be the center of the center. Yeah. I'm going to say, I think that was rude, but okay. I'm just passing the message on. Cynthia here? Yeah. I bet you. Here's the question. Good thinking. But could you have multiplied this by 4 to get to there? 2 times 4 is 8. It should be at 16. So you can't just multiply. You have to mile your way. Right? So what would you do to get the next one? You multiply by. And then to get the one after that, you would. Okay, do that up to 10. You can do it. You can do it. I think you can do it too. I say you too. Yeah. Because get here. Every time we add a new switch, we double our options, right? So all the options we had before. Here we have the option up or down. And now we have the option up with up to start, or down with up to start. Right? And then up and down to start, up and down. Every time we do it. Right? So this one, you don't have how many options?
Yeah, but it's easier, you don't have to search up.
Follow the pattern. Tell me how many 5 switches. Tell me how. What do we do every time? Yeah, so what's next? Well, what's the next one be after that? Keep going, okay? You got that? Good job. That's good to me. Hey, focus. You can, I was going to say cyberbully, but that's on paper. You can paper bully each other later. Get to work. I'll punch you. I'll fist you. How do you feel about that? I feel like you would take me, but I feel like I could take her. Maybe I'm being unfair there. Then maybe you would take me. I don't do anything. You think they need your help? Or are you helping me? I don't, they don't need your help. These two need you? Get to it.
Yeah.
Yes, you're going to go there as well. Up on the desk, okay? Yeah, you can. When you go back, what do we think today? What do we think? Junior. How do you do that? I don't know if you explain. Oh, you don't have to help. You just gave us this thing. So, we said that with this pattern, it's a kind of pattern that we're not used to, where we're not adding every time, instead, we're multiplying over and over again, right? And we said the pattern is we keep multiplying. So the fourth position, that's a highlighter, the fourth position had 16 possible settings. What would the fifth position have? Yeah. I thought that was a hand. You were just slicking your hair. But that's okay. What would the fifth have?
32.
How did you do that? You're totally right.
Doubled it.
Good. We just double it. That means the sixth position is going to have how many possibilities? Very good. And how did you do that? You doubled it. Very good. What's the seventh position going to have? Or seven switches? 128, because we doubled it. The eighth position, how many are we going to have there? 256, awesome, very good. What about the ninth position? What's it going to have? I keep looking and seeing a hand over here, and that's an umbrella. And I don't think the umbrella is going to answer my question.
I'm going to let you answer. If that umbrella's in the air, that's as good as a hand.
No, that's his choice, but do you have an answer?
Yeah.
Do you know how many the ninth position will have?
512.
Very good, how'd you get that?
I just multiplied the last one by 2.
Very good. And the question was the 10th position. How many will the 10th position have? Or the 10th lock gives us what?
1,000.
Very good. 1,024. Okay. Look here. That's a really, a lot more combinations than we started out with, isn't it? Like, this grows pretty quickly. If we kept going, it would grow even quicker. So now, and by the way, like a couple people stopped at 512. You just didn't go the last one. That's great. You're doing great. You get the idea. And it actually leads to, look here, is doubling over and over again pretty simple math? It's not too complicated, right? And yet, if I had asked you for the 100th, a lock that had 100 of these, would it take you a long time to do that? Yeah. And would it be easy to make a mistake and do one too many or one too few? Right. So wouldn't it be nice if there was a way to do this quickly? Because remember, you know how when we add, if we say add 2, then add 2 again, then add 2 again, then add 2 again, then add 2 again? Eventually in math we said, geez, adding by the same numbers over and over again is complicated. And they invented what operation? What operation means to add over and over again? Keep adding. Multiplication. Addition is doing it once. Multiplication is adding a bunch of times. Does that make sense? We can do the same thing for multiply. Let's actually look at the next page. Because what we really did on the last page was this. We said, how many settings are on my lock? Well, the first one gives me 2. The second lock doubles the number of settings. The third lock doubles the number of settings. If I wanted to do all that math just in one step, I could do it in one step. I would just say 2 times 2 times 2. How many of these am I going to have to write to answer the question we just answered? How would I get how many 10 locks? Yeah? Sorry, not the 100 question, just the 10 question. Yeah, good. So look here. The example we just did is 2 by 2 by 2 by 2 by 2 by 2, 1, 2, 3, 4, 5, 6. By 2, that's my 7th. By 2, that's my 8th. By 2, that's my 9th. And by 2, that's my 10th. And listen, if you do that on your calculator, it'll give you the answer. You don't have to make a table and write it out. We could have just said, why don't I have a calculator here? Oh, way to go, Joe. There we are. 2 by 2 by 2, 4, 5, 6, 7, 8, 9, 10. And lo and behold, does it give us the right answer? Because that's all we did, right? We just kept taking numbers and multiplying it by 2. Now, having said that, is this messy and clunky? And easy to make a mistake? I think so. So is there a way that we can write 2 times itself 10 times that isn't so messy and clunky? And of course there is, because otherwise this would be a really stupid lesson. And the way we do it is this. We use something called a power. Another term you'll hear is what word? Exponents. And they're related. An exponent is actually part of a power. We'll talk about that. But if you hear the word exponents, it's related to the same idea. A power is a way of writing repeated multiplication like this quickly. All right? And what we do is this. We have a base, and this is some number, a base, and we have what do we call the little number that goes up here? What do we call little numbers up there? That's what we call the exponent. Good. These two things together make a power. Every power has a base and an exponent. And what it means is, I want to use a different number. What it actually means is multiply this number this many times. That's what it means. It means take the base here and multiply it together this many times. So if I had, 4 to the exponent 3, what is that telling me to do?
12.
No, it's not 12. What's it telling me to do? Sorry? Do 4 3 times. So 4 times 4 times 4. Those mean the same thing. Hey, which one of those is easier to write? I mean, you may differ. I think that's a lot easier to write, don't you? You don't have to write these examples yet, by the way. We're going to do lots of examples. What would this mean? Nice place to get Slurpee. What does that mean? 7 to the exponent 11. What's it telling me to do? Yeah?
Multiply 7 by itself 11 times.
Very good. 7, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, which one of those is easier to write? The exponent, right? So I think sometimes in math we get thinking like, oh, these things are complicated and confusing, but they just exist to make your life easy. Nobody wants to write this, so we write that. So let's look at our bank example where we wanted to figure out what 2 multiplied by itself out 10 times is. How could I have written this as a power? What could I have written? If I wanted to write all of this as a power, I meant to get the yellow calculators, so we all had the same calculator. Do you mind? There's a cart in my room, Mr. Calford, and if you just bring the cart down. I'm so sorry.
I'll bring one of my rows too.
Beautiful. How would I write this as a power? Yeah.
The base would be 10 and the exponent would be also 10.
Very good. And, you know, the one challenge with this question, yes, that is true, but that's not what we actually did, is it? Can you guys do me a favor? Is this what we did on the last page? No, what did we do? Yeah, we didn't do 10 times 10. We did 2 times 2 times 2. Can you all change that? I am really sorry. That was some shoddy note making on my part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what they call that? A mistake. I done goofed. I'm really sorry about that. But you know what? The great thing about doing math is when you make a mistake, you can always just fix it. So we fixed it. So how would I write this example? How would I say multiply 2 by itself 10 times? How do we write that as a power?
2 would be the base and then 10 would be the...
Good. Another way of writing that is 2 to the 10th power, 2 to the exponent 10. And I want to use a few of those phrases. We could call this 2 to the exponent 10. That's a way you'll hear people say it. What's another way you might say that? 2 to the exponent 10. What's another phrase we use? Because you'll hear them all. Yeah, you could say 2 to the power of 10. And listen, if you know this, you don't have to write these, but I think it's kind of good to have down there. What's another way we could say that? You might say 2 to the 10th power. Anyone ever heard it said like that before? And sometimes we get lazy and we just say 2 to the 10th. All right, if you do a lot of math, slowly but surely you start stripping words out and you just say, 2 to the 10, 2 to the 10th. So just so you know, I will always try to be really careful and say one of these two, because those are kind of the most formal language. But people say all kinds of different things to mean the same thing. Does that make sense? All right. Mr. Calford's going to get our calculators. So, you know, we'll wait a minute. But even on your phone, there's 3 main ways they show this. One is with a button that looks like this, X to the Y. Sometimes you'll see it like this, A to the B. And then what I actually think is the best one, but it's not the most immediately obvious, is do you see this one? This one literally just means like this number I'm about to put in, like shove it up there, put it in the exponent. Does that make sense? So if I wanted to do 2 to the 10 in OneNote, and OneNote is a calculator, OneNote uses that little symbol, what we call the caret, to do an exponent. So I, on OneNote, would say 2 to the exponent 10. Does everyone see that? And that's what that means on OneNote, and it knows that the answer is. Isn't that a lot easier than saying 2 times 2 times 2 times 2 times 2 times 2 times 2? What am I at? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Like, I don't know about you, but I would much rather punch that into my calculator. Don't you think? Okay. Just to show you different calculators, if you just go into Google, or Bing, or whatever the case may be, they use the same. They have that little symbol there. If we go into Desmos, most online ones are similar. Desmos, on the other hand, has a little button, A to the B. Can everyone see that? So here I would say 2, then I'd press that little A to the B button, then I'd press 10. Do we all see that? So you've got to know what your calculator uses. Now right now we are handing out to you a calculator that everyone can at least have the same.
I know that you guys have great calculators, some of you have a phone that does not use calculators. But we do want everyone just to know how to use this one anyway, so even if you have your own.
Yeah, guys, this is kind of just our default calculator. It's one we use a lot. One number.
Has been gone for
Yeah, this is brand new, and let me tell you, this is like $6,000, well, $4,000 worth of calculators we just handed out to you, so that's exciting. Anyway, I want you to get some practice. See if you can use your calculator and evaluate these. And they start out pretty simple, and then I get a little bit tricky. Very little bit tricky. I hope this is good. I was worried it was maybe going too far, but I think this is A. But otherwise, what did I put? Oh, I did. So good. Oh, that's because I was originally going to do 4/3 pi r cubed, and then I chickened out on 4/3. Which I shouldn't have, because they could totally do that.
I have a simulated one that would maybe.
Yeah, I have the simulated one too.
Did it run? Sometimes it doesn't.
But I don't know. You know what?
I'll dump it and.
Oh, that is the management app, but I want the simulator. Yeah, where'd you dump it? Just in teacher stuff? Yeah. Cool. All right, so guys, I'm going to give you, I don't know, 3.5 minutes. See if you can work out those calculations using the power button. Strategize. Yeah. Oh, I feel like a real East Dale teacher.
First, I should mark Lucas. Not this time.
Yes. I know of whom you speak. Oh, it's just giving me a shortcut to the executable. There's the executable somewhere else. Can you show me your folder where the executable is?
It's probably just loading it.
No, but it specifically says shortcut. Unless I'm crazy.
So you want to click on...
Oh, the one down there, VTI. I see it.
Yeah.
I see it. Aha. Aha. The one that says .exe. Executable.
Next.
I definitely need to just download the whole page.
Can you force to download everything?
Yeah, you just keep online. But I need to revert this to Windows 10 until there's just some weird stuff going on with like you can see with no, I know, I'm just trying to
Oh, I see.
like you have to say skip and that downloads it and then
Because it's looking like it doesn't have half this thing.
skip and then it'll download it. And it's like, okay. Yeah. So I gotta, it's good to be on.
Better to run it on a USB.
Yeah, that might be good. That's okay. Just gives them the experience.
Flashlight feels so old to use.
I know. When's the last time you put one in your computer? When in doubt, second function that is quick. When in doubt, I'm done. Yep. Just, what are you going to put instead of S? How does it S is equal to? Try it. I'm going to give you 2 more minutes.
You now have it on your desktop.
Beautiful. Oh, yeah. I'm really enjoying all the Windows 11e new features, but like the core integration of OneNote or OneDrive is just not quite working yet, and it causes me anxiety.
My friend's back again. Hold on a sec. Bottom left.
Oh, I know who you're of whom you speak.
She has to go get her retail water, so she's waiting for this room to come back. So when she gets back,
Hi.
Hi, for the pi symbol, did you just write 3.14?
That's what I would do.
Okay, so there is no pi symbol on this?
There is, but I would just do 3. I gave you to use 3.14, right?
It just says a pi sign in like the equation.
Yeah, you can use 3.14. It'll be good. There we go. Yeah. Ask Mr. Kelford is managing door in and out right now, and he'll tell you who you have to wait for, because we got a few people out right now. All right, guys, I'm going to take your attention up here if I can. Shh. Okay, quiet down. Settled in. Okay, my calculator here is a little different than yours, but it's the same basic design. Thank you, Mr. Kelford. So for this first one to put it in, this is a nice straightforward one. How would I plug that into my calculator? What buttons am I pressing? Yeah. 5. Great. And do we see on these calculators, we always do an exponent with this button here. So 5 to the exponent 3. Now mine just shows it like that. I think these newer ones actually put it up in the exponent, which is even nicer, isn't it? I think it does. And when we did that, what did we get? Excellent. I got 125 too. By the way, we're not going to do this every time, but remind me, what is this telling me to do? This is saying take what number and multiply it how many times? It's saying take the number 5 and multiply by itself how many times? 3. Now, we're never going to, oh, not like that. We're never going to write it out like this every time because that gets clunky, but just to show you that that is in fact the same thing, there it is. Okay, what's this next one? Take 8 and multiply itself 4 times. How do I plug that into my calculator? What am I going to press? Yes, ma'am? Yeah, and really get in the habit of every time you press that button, say to the exponent of or to the power to. Give yourself that mental exercise. What do we get when we press 8 to the exponent 4? What's that give us? Should be a pretty big number.
4096.
4096. Good. 4096. Excellent. The next one, how do I plug that in? Oh, someone new. How do I plug this one in?
What's that, Murray? Didn't hear it.
Yeah, I can.
Yeah, what do I press?
You press 3.
Yep.
What is that called again? The
Eyebrow button.
You can say, but I also want you to get in the habit of saying like the exponent button or to the exponent of.
So then
Yep. 7 Very good. should equal 2,187. Very good. Okay, this next one sounds complicated, but they've told you what to do. We're going to take some number and put it to the exponent 3. And then they tell you what number to use. What number are we supposed to use? Yeah, so all this means is 5.4 to the exponent 3. How do I do that in my calculator? Well, 5.4 to the exponent 3, and that should give me
157.6464.
very good, 157, and yeah, as it happens, decimal 464, 464 thousandths. All right, this next one's a little tricky. What would I plug in here? This is saying, and by the way, as Mr. Calford correctly pointed out, that's not a volume formula, it's an area formula. So, boo to me. 0 points for Mr. Orlando today. But having said that, how would I calculate this? What would I plug in? Do we know what pi is? You could use the pi button if you can find it, but if I had to put a number in for that, what could I put in? What's pi? So I could say 3.14. And then it's right next to something. In math, when something's right next to something else, what am I doing?
I think we should probably show them how to use the pi button as well, because it's second feature, right? Shift.
I was going to do it in the next question.
Oh, okay.
I got your back. So I'm going to say 3.14, and that's right next to another number. So in math, when it's right next to, what's that mean?
Multiplying.
Good, so I'm going to multiply it. 3.14 times. And then R, do I know R? Yeah, why? What's R?
6.3.
Yeah, how'd you get that?
Because it says right there R equals 6.3.
Good. The question's telling you what to use. We're just trying to give you a little practice here of substituting values into an equation. And will I be done? Do I press equals there and it'll give me the number 3.14 times 6.13?
No.
No, what else do I have to do?
Well, you gotta get rid of that 1 in between the 6 and 0.13.
No, that's
The 1, like.
oh, it's just 6.3.
Yeah.
Oh, silly me, I'm sorry. Thank you for telling me that.
Where's the phone party at?
3.14 times, it's right on the papers there, times 6.3. Cool, now am I good to go? Or is there something else I have to make sure I don't forget? Yeah, the exponent. And in this case, the exponent we're putting 2 is 2. And how do I do that on my calculator? Yeah. And then? Awesome. And that is 124.6266. All right. Last one. If I want to put this in, I can say 2. And then do we have pi? In fact, it's in a really convenient place. Can anyone see on the calculator where pi is? It's a button we've already used. Yeah, beautiful. What a great answer. If you actually look, if you press second function and then the exponent button, it's actually kind of nice. The second function of the exponent button is pi. So I can do 2 times pi. And then what do I have to do with pi? I have to make sure I put pi to the exponent. To the exponent. I got to put pi to the exponent 5. So I'm going to press that. And then multiply by, what are we putting in for k?
7.65.
Times 7.65, and what exponent am I putting that to? To the exponent 4, yeah, very good. And that gives us a big old number.
Your calculator takes care of the order of operations, but you should notice some common, errors that people make with an exponent. They might multiply 2 and pi together, and then raise it to the exponent 5, which would give you a much larger number.
Yeah, I will say, guys, the nice thing about modern calculators is if you're careful with them, they do a very good job. So if you're careful about putting it into your calculator properly, it will actually sort out the order of operations, but you need to be careful not to outsmart it. Yeah, don't do 2 by pi and then do the exponent.
The 2 is not actually being affected by that exponent of pi.
No, just the pi. In fact, we'll talk about that in a little bit. All right, so that's exponents, and you've probably worked with them a little bit before. From there, we're going to talk about something. How many of you are in science? Yeah, most of you. So this is going to feel reductive. You're going to feel like you've seen this before. But I want you on your calculator to calculate 2 to the exponent 64 for me. By the way, if I wanted to write that out fully, what would I have to do? 2 times 2 times 2 times 2. How many of these would I have to put? Yeah, am I going to do that? No, I'm really not. I'm way too lazy. So do that on your calculator and see what it gives you. Do that on your calculator, see what it gives you. 2 to the exponent 64. Okay, let's take a look. Does anyone notice anything weird about the answer? There's an E. Okay, let's talk about that. Listen, look here. 2 to the exponent 64. Now, let's get the first thing out of the way. Is this really telling me that the answer is 1.8? Do you think that if we multiply 2 by itself 64 times, the answer is going to be 1.8? That doesn't even make sense, right? So we get 1.844674407, and then we get this weird thing. And, we are high-tech enough now that I wish it didn't show this, but actually just showed what it should. But that's okay. This is telling you that this number is in something called scientific notation. Now, if you are in science right now, I'm afraid you have a bit of an advantage right now, right? Because if you're in science right now, well, we've already done this. But if you aren't in science right now, that's okay too. Because we're going to take a minute and look at this. What this number is actually saying is this. It's a really big number. And I want you to think about it this way. If we have the number 3, that's obviously easy to write. But if we have 30, how would I write 30 in scientific notation? I'm just going to jump right to it because I know a bunch of you have already done this. Then we'll talk about how it works. If I wanted to write the number 30 in scientific notation, how would I do that? Oh, surely you haven't all forgotten from our space unit. What would that look like? Well, I'll say this. We can think of 30 as just being 3 times 10. And we can think of 300 as being 3 times 100. And we can think of 3,000 as being 3 times 1,000. Does that make sense? These are the kind of ways we could break a number up. And so in scientific notation, what we do is we say this. We make every number a 1-digit number, and then we say how much bigger it should really be. Does that make sense? We make every digit a 1-digit number, and then say how big it should be, how much we moved it. So what this number that your calculator actually spit out was a big number, 1.8464, but what it's really saying is, to get what this number really is, you would have to take that decimal place, and you'd have to slide that decimal place over a bunch. How much? You'd have to slide it over 19 times. That's scientific notation. Now, your calculator does that with an E. But what we usually do is we say, to make 30, we would have to take 3 and then move the decimal place once, so we call that multiplying by 10, because we count by tens, right? So every time you multiply by 10, you move the decimal place over. To make 300, we start with 3, and then we multiply by 100 to move the decimal place twice. But the problem with this is, I'm now writing a number just as long as the one I wanted. So what we say is, make 3, then move the decimal place, but don't move it once, move it. How many times do I have to move the decimal here? I have to move it 2. So that means multiplying by 10 twice. Does that make sense? We use an exponent. To get 1,000, we start with 3, and then we move the decimal place 3 times. Right? What about 30,000? Well, that would be 3 times 10,000. But really what we want to say is make a 3 and move that decimal place 4 times. Does that make sense? That's not too bad, is it? Obviously, what would this one be? This would be 3 times 10 to the... How much? Yeah, very good. And 3 million would be 3 times 10 to the 6. Very good. So, scientific notation is a way of using the fact that multiplying by 10 just slides a decimal place to say if I want to express a really big number, I can just say the first digit, and then say this digit, and then move the decimal place 6 times. By the way, does it only work for really big numbers? What if I had decimal 3, or decimal 03? Well, I could still do that, couldn't I? This would still be 3. I'm still moving the decimal, but how am I going to express that I moved the decimal the other way, because it's a small number? We're not really multiplying by 10 here, we're actually dividing by 10. Yeah?
You put like a subtraction sign.
Yeah, very good. We say move that decimal place once, but you move it in the other direction. Move it really to make this a small number. Really what we're saying is don't multiply by 10, divide by 10. But don't worry about that. You'll see that in grade 11. I'm assuming still grade 11?
I have a second cycle.
Oh, that's right. We do negative exponents. You'll see that next cycle. How would I write this one, do you think? How would I say it's 3, but we have to move that decimal place twice? How do you think we'd write that? Yes, sir?
3 times 10 and then minus 2.
Very good. 3 times 10 to the exponent negative 2. So that's the basis of scientific notation. Scientific notation says we write just a 1-digit number and then we say how many places that decimal has to move. With a bit of practice, you'll get really good at it. You know how I know that? Our science guys had 1 week of practice, and I think over 85% of you got perfect on that section on the test. So that was great. You did really well, which tells me with a bit of practice, you guys will do great. So we can do this for big numbers. When you have a big number and you want to put it in scientific notation, excuse me, too much talking, we write it as a 1-digit number. So we write all the same numbers, 6, 3, 4, 2, but to make it a 1-digit number, where does that decimal place have to go? Where should the decimal place be for this to be a 1-digit number? What do you think? For it to be 1 digit, the decimal place has to be after the first number. That's what we always do. Decimal place goes after the first number, and then we just have to say, how much did I have to move it to get there? How much did I have to move this one? Yeah, 2 places. So how would I say that here? 6.342 times 10, that means move that decimal place, because we count by tens. How many times am I moving the decimal place? 2. I want you to try this. Try these questions here. Shouldn't take you long. I bet you it'll take you 3 minutes. Try them out. And for the guys who aren't in science, I know I'm probably taking this a little quicker than I normally would because a lot of people have already seen it. So if I'm going too fast, please don't be shy. Just say, hey, Mr. Orlando, I think you're going too fast. I'll slow down. Don't be shy. Put your hand up for help if you want it, if you need it.
If you have more streams, press again. And that's not straight messed up. Second plus sign stuff on 2 is reset.
Right. Oh, you got one. All right, yeah, throw it. Okay, how many places with that one? Put the number back away.
Cool. Can you do me a favor? Can you put those on that?
Yep, it's totally doesn't only once you look at this, time spent probably
Oh, yeah. Yeah, if I have to take your phone,
if I have to take your phone, then I get the benefits. No, because it's been nice. People being self-regulatory. The industry is nice.
Really? Oh, I'm no, I was not. Yeah, don't get taken away next time. Nope.
This one is where you
I also did all the missing.
always put investment places in the same spot.
Oh, right.
Always.
Yes, I got all my
Doesn't always show the way to one district. And then you want to say, okay, how much should that be? How much should that be? One.
I missed the.
Does that make sense? So 10, and then we go, yeah. Awesome. Yeah, this one, yeah, how many times do you have to move it? You have to. Awesome. Now here, this is the decimal ones. But the number of them, that's what we're right now. So that's the law. Well, not good, that'd be 0.345, that's it. You can tell, yeah, right away. What you know is all of a sudden we added 0.2 says, super long calculator, right? Does that make sense? So that's what we're going to do. Okay. So now this one, we wrote all the digits out, where are we going to do that? Because this is the same thing, just cut the whole thing out. Scientific innovation, we always put it. So what's here? Yeah. Awesome. E. Awesome.
Times 10
Now here,
exponent.
by the way, I'm going to mention.
So the number is too big to display. So we express it as a 1 negative number multiplied by a power of 10. So that's
I just want to kind of, one of those. I can do
too big to display, like a single digit number.
We're always 10, that's only make it one digit number. Like also. Just, you know, it makes rounding. Okay. And now, how does it do this? Good.
Use your device and do that. Thanks a lot. From last week deciding to do that.
You don't ever practice.
Yeah.
Oh, man. Okay.
Trouble attending regularly.
That's great. That's great. That is.
I know you gave the one that you felt like, we missed all of.
Definitely can't do that.
That's fine if you felt like you should say, but it does
a little
not.
Show me you put that in. It probably works.
We'll be glad you're here to learn. Let's just be down on the road. But anyway, it's a good start. It's Monday and here's lunch. Forward to every day this week. Good to get the data.
That just seems like
nothing built up.
That's awesome. Awesome. These are tricky. That's okay. Don't stress out these words.
You guys have science?
Today I'm going to run. That's what I'm reviewing.
So one.
I have it. Like I'll send it to you right after school. Yeah, I've got to run away. Try it. Can we try again tomorrow? I think tomorrow should be good. Sorry, my notes to stick on. Yeah, I have basketball. So I gotta use that. Okay,
Just wanted to make sure that's why.
no, I appreciate that.
Oh, nice. Beauty. Man, I lost my ability to teach a lesson in I have.
Well, it's a big crowd here. Someone needed, that they pointed out a missing exponent on that number.
Oh, I didn't put
Missed
that.
the full
I didn't. Thank you.
Math's credit there.
Oh,
We introduced the math fame payout. I don't know.
Oh, we totally should. You know what the real shame is, Calfred? If we track who's responsible for those payouts, like have them come out of your account or mine, it's going to be a sad state of affairs when we realize that it's like 10 to me for every one of yours.
So that.
Yeah, real quick.
Oh, sorry. You just want to go till you get to a number. So 1, 2, 3, 4, 5 spaces to get to a limit. Between the 3 and the 2, you know where the eraser can just go on. And then change the exponent and just go -1. Right with the negative number, the number gets smaller.
Pretty obvious. Here's that gas going.
My son gave me math rules.
Have you heard the Joker? It's so good. It's better than the original. That's way better.
All right, Steve, let's take a look up here, shall we? So, these were all very nicely done. Not these ones. I did those ones. But these were all very nicely done. So let's take a look. Guys, can I look here? All looking here. When we come back from break, A, you should be back on time from break. B, oh, someone's talking while I'm talking. I'm not caring for it at the moment. Thank you. Thank you. When we come back from break, we should certainly make an effort to be on time. I know it's quick. I know that if you have to go to the bathroom and get back, that can be tight. But certainly if you're coming back from break and you are a couple of minutes late, a good rule of thumb with that is slide in quietly and unobtrusively. It is kind of the height of rudeness to be being noisy when you're on your way back in. So keep it down. Now let's take a look here. These ones here, very nicely done. And remember, the trick to it is you take whatever digits are here, you write it out so that's a one-digit number. So that the decimal place is after the first digit. And then your only job is to say, how many places did we have to move the decimal? So here, how many places did we have to move it to make it a one-digit number? 3. And so it's 1.745. Make sure you don't accidentally write that decimal place twice. Easy mistake to make. We all do it. And we moved the decimal 3 places, so that's times 10 to the 3. How many places did we have to move it here to make it a 1-digit number? Just 1. So it's times 10 to the 1. Here, there's no decimal at all. How did he do this? Is he just a super genius? How did he know how to do that? Yes? Yeah. And if you think about it, if I said make this number 0.1 bigger, you'd know that it was 345.1. So you know where the decimal is. If it doesn't show you a decimal, the decimal is at the end of the number. And to make this a 1-digit number, how many places did I have to move that? 2. 1, 2. We get 3.45 times 10 to the 2. This is a big, messy pile, but that's okay. How many places did we have to move the decimal? 1, 2, 3, 4. And so we rewrite all those, but with the decimal there, and times 10 to the 4. Now, one of the nice things about scientific notation, it actually lends itself very well to rounding. If you wanted to, you could round and erase a bunch of those digits, and it's easy to do that without losing your spot, which is nice, because that's a lot of digits to write. Now, we're only going to take a couple more minutes on this before we move down. What about a small number? Well, it's the same thing. Here, to write it as a 1-digit number, you're going to take the same digits, 2, 5, 6, and 7, but where should the decimal be if I'm writing this as a 1-digit number? Yeah, right there. And so how many places did I have to move the decimal to make that happen? Perfect. So the correct answer to this would be 2.567 times 10 to the 1. It should be. Why does it need to be negative? Because it's going backwards. And listen, guys, there's a lot of different ways to remember this. I think it's foolish to try to be like positive is left, negative is right, or any of that. To me, it's simple. If you're making a big number, that's a positive exponent, right? If the number we're talking about is a big number, use a positive exponent. If you're using a number that's less than 1, a small little decimal number, then for that, we're going to have to use a negative power. And I have found that if people use that as the memory tool, we're in good shape. How would I write this one? We'll do one more together, then I'll give you a minute to do it together. Yeah. Good. It's going to go right behind the 3, so this would be... Now, do I need to write all these leading digits? Should it look like that? And I guess that isn't even technically wrong, is it, Mr. Calford? It's just weird. It would be like me saying, I'm 00038 years old. Not false, but weird. So usually, any zeros that end up in the front hanging like that, we would just get rid of. Now, how many places did I have to move the decimal to make that happen? 1, 2, 3. So I should say times 10 to the 3. Negative 3. Negative 3 because it's a decimal number. I'm going to give you 1 minute and 46 seconds to do these 3. 1 minute, 46 seconds. You got this. Yeah, that's perfect.
So this is the equation.
I suppose.
Yes.
I don't know, like, what are you doing on that? Why are you on your phone in my class?
I'm done.
Okay.
So that's it.
Yeah, but I know, but I'm just thinking my way through it. I'm not giving you a tech. I'm just.
Do you want me to write them all, or?
Sorry? No, I don't know if that's how that works. Like, if I, like, to be honest, like, I don't know.
Do you want me to write them all, or like all 3? Or?
Have you done your bank transfer yet?
Yes.
Okay, then yeah, go nuts.
Superman has on my arm.
Does he want me to write them all? Mr. Orlando. I just don't want to write them all and then he'll be like, why didn't you? I don't know. I'm not going to write them all anyway because I don't want to like, I don't know. I think I did that, right? Yep.
I think I had like 5
Oh, that's tough. I think I had to decide which one I wanted to do.
Mr. Orlando, you can have that.
Thank you. Yeah.
Do we have to like take a picture of this and put it on the...
Not this. Nope. All right, guys, let's take a look up here. I saw some good-looking work out there. And in this one, to make it a one-digit number, how many places did we have to move that decimal? Twice, right? And so what exponent do we see here? -2. Looks good. This one, we had to move it twice. And what exponent do we get? -2. And this one, 1, 2, 3, 4, 5, I had to move it 5 times, so the exponent is -5. You guys did great. Those look really good. And I saw a lot of good work out there. Listen, this is the kind of thing that lends itself really well to like throwing 3 questions out at the beginning of a class, just real quick. You'll get a lot of practice with this. I promise. Oh, I feel like I'm talking over people.
We see a lot of note passing. Just know that we'll, I don't know, do something that publicly humiliates you if you're passing notes in class, so I wouldn't do it.
Now, the last thing to know with this before we go on to the second half of the lesson, and I need you to be quiet and focused so I can move at pace because we have a whole second half of this lesson. So settle down. So if we are given the number as scientific notation, what do these instructions say? Well, this says this number is 3.2, but really, how far away is that decimal place? How many places do I need to move it? 3.2, but move the decimal place 3 times. Very good. So I'd do 3 and 2, but then I'd go 1, 2, 3. Okay, my decimal place is there now. That's great. I moved the decimal place once, twice, a third time. So my answer is 32 space decimal. Not a very compelling answer.
You have to put the zeros in the spaces.
Very good. Those spaces have nothing in them, and math has a number for nothing, or at least nothing that we know of. We don't know what those values are, so we fill them with what we call a placeholder, but we fill them with 0. This number is 3,200. If you're left with a blank space like that, you have to fill the blank space in with zeros. What is this one saying? This is saying the number is 145. The decimal was here, but it's saying move that decimal place. Yeah, it's moving it 3 times, and this is telling me it's a small little number. So I can't move it this way. That's going to give me a big number. I need to move it this way. 1, 2, 3. And again, I end up with these blank spaces. What goes in a blank space? Zeros. Now this one, you can actually write 2 different ways. That, to the best of my knowledge, Mr. Kelf, is it fair to say these are equally acceptable?
I like to see the 0.
I like to see the leading 0 too. Like this is correct. I think this is better. Like I don't think we could say that that's wrong, or can you? Is the leading 0 necessary?
A lot of calculators will actually output it that way.
Like just decimal 0.
Yeah.
Interesting, yeah.
I missed that it's a decimal.
Yeah, I would say I prefer it with a 0 in front. That to me is kind of better manners, but it's the same answer.
Then you have 0, whole place, and then this piece of the tiny.
Yeah. What would this one be? Well, I'm going to give you 2 minutes to fill these out, and then we're going to move on to the next bit of the lesson. 2 minutes to get these 3 answers, and then we'll move on to the next part of the lesson.
The homework page and the homework.
Yeah, it is. We're going to push you right to the last minute today. Well, you know what that means. Fill me in, crew.
Why?
Because I have, and you appreciate me.
What? Do I now? We're supposed to? Me and my broken hand? You do it first. No, I'm not. You do one first, and then I'll do the next one, and then you do the last one. So you do the next one. Make sense, right?
Wait. I'm trying to see which one should I do.
Do the easiest one. Mr. Orlando, I broke my water bottle. Can you replace it for me? Look at it. Look at your font.
I'm gonna make you do the hardest one.
Mr. Orlando, my water bottle.
Yes.
Oh no, you killed that.
3, 2, 4, 5.
Want me to do that one?
Yeah, you do that one.
What?
You do the hardest one.
It's not that hard. I just don't remember doing it.
No, you didn't.
My
I'm
water.
scared. 7, 2, 8, 7. What?
Good writing with your broken hand. Boom!
I did it.
Wow.
Are you proud of me?
All right, team, let's take a look up here. Woo! Okay, we have some really nicely done work here. Let's just quickly check it. This one is saying to get the real number, we have to move that decimal place twice. And sure enough, there it is. Good job. I actually really like, hey, oh, I still feel like I'm talking over people. Not a thing I care for. Thank you. I really like this answer. They didn't even bother to show the decimal place, which is appropriate. That's fine, because we've said that if the decimal place is just at the end of a number, you don't have to show it. So that was great. Good job there. Here they said move the decimal place once, and so I think that should be 32.45. Oh, why did they put 0.3245? Doesn't it say to move it once? Yeah, it says move it backwards. It says it's going to be a little number. And here it says move it 4 times, 1, 2, 3, 4. And that puts the decimal place at the end again. Good job. All right. This topic, powers and scientific notation, it is one that we're going to use these skills a lot. It's really a skill-based thing. So we will plug away at that. You are now going to get a lesson on appreciation. And so while you're getting the handout, I just want you to take a look at this. I just want you to take a look at, because I want to think, a classic case of saying, I notice and I wonder. So I don't know if anyone here collects Funko Pops. I don't know if that's like, you know, so out of date. My kids had a lot of them. I think they still do. But I want you to take a look at this and just think about it. Yeah, kiddo, what's up?
I was doing that or whatever. Why is it all black?
Because I don't want you to have to go back for these, because writing that out 14 times would be annoying, and writing that out 14 times would be annoying. I'm just trying to save your work. Does that make sense? Yeah. Time to think about this. What your questions are? About an hour. Just do it.
Funko Pops. I've never actually heard of Funko Pops.
Oh, really?
Yeah.
Oh, like my kids have 100. That's like a little collectible. They're just like, they're cute.
I remember those little lunch or whatever things, like they're like little food.
Yeah. I don't even really understand this company because they just, like, there's a Funko Pop everything. And it's like, how do they get the licensing for all this stuff?
Yeah.
Like, I don't really get it from a, like, legal perspective. All right, guys, let me ask you, what is this graph telling us? What do you notice? What do you wonder? What's something somebody noticed? What can you tell me? Yeah. Ah, so it tells me how expensive things are. It goes by expense. Sure. Okay, what else do you notice?
Creating a definition? Something you notice? Anything?
Yeah, what do you notice?
Okay, it goes up. In which way?
Yeah, so they've like put them in order. Like these aren't random, right? They've chosen an order. On the left, they've put the most expensive one, it looks like. Sure. What else who else has something they notice? Mr. Galford, what do you notice?
They're cute. I don't know.
They cute? Okay. Sure. Sure. Does anyone have a deeper insight than Mr. Calford? I don't know if that got full marks from me. Yeah, what do you think?
It tells us the name of each.
Oh, yeah, we get the name of each. I mean, can somebody just give me one fact that this gives them? Like, can somebody give me a really specific fact? I'm looking, yeah.
They're all bad.
Oh, I don't know if I agree with that. But okay. Yeah. Yeah, so you just, the number of them. Cool, that's a fact. I like that. That's interpreting. By the way, is this every Funko Pop that exists? It's the most expensive. Hey, and I find the answer to this a little depressing. What's the most expensive Funko Pop? Yeah, I have mixed feelings about that. That's our most expensive. Can you imagine paying, how expensive is it? How much would I have to pay if I wanted to buy Malcolm McDowell from A Clockwork Orange, which appears to glow in the dark? Yeah. Oh, good. And can I say, you even knew K was 1,000? I love that. 13,300 bucks. Would you pay 13,300 bucks for that? I would not pay 13,300 bucks for that. Okay.
I think I noticed something else that you kind of lose value quickly at first and then not so much toward the end.
So there's like a big difference between the most expensive and the least, yeah. But not a big difference between the second least and yeah.
Superman and who was before Superman?
I don't know, we're loading.
Right, like there's not much difference between Superman and Freddy, but there's a big difference between our orange glow guy and Freddy. How come it seems like Funkos? Oh, one is Jamie Lannister and Bloody. I don't know any of this.
Yeah, can I say, if we want to talk about feeling old, I would say I know not many of I don't know what many of these are referencing. Venmo, Stan Lee, sure. Clockwork Orange. Oh, Jem Lannister, okay, I know that. Oh, Count Chocula, glow in the dark. Boo Berry. Would you pay $10,000 for a glow in the dark Count Chocula Fun Pop?
I would actually.
Well, there you go. Now we know who's driving the price up. Okay, so can I tell you what I wonder?
Why they're expensive?
Will these be worth this in 10 years?
It'll be more.
Do you think so?
Yeah.
Like, I wonder, like, will that keep going up? Like, if I have my Boo Berry Funko Pop and I'm going to hold on to that until I'm ready to retire, will I be able to sell my Boo Berry glow-in-the-dark Funko Pop and just buy a house in, like, the Caribbean?
Yes.
I hope so. That'd be a pretty good gig. Like, is Freddie Funko Jamie Lannister body really gonna like just make my way in life? Did anyone else wonder anything different? Does anyone collect anything that they think they collect it because they think one day this is going to be worth money? You do? Yeah, what do you collect?
Honestly, I just gotta say, you're selling a plastic toy for $14,000.
Sure. Yeah, a lot of money.
You sell 1 cent from 2 cents.
Yeah, like listen, let me tell you, like when I was a comic book kid, I really loved comics, but in the 90s, everyone was buying comics thinking they were really going to be worth a ton of money in the future, and like they were starting to go for $10,000, $50,000, $100,000, $1 million, and like comics are still valuable, but they're not quite that valuable. They went down since the 90s. It wasn't quite the boom people thought it was going to be. Guitars were like that. In the early 2000s, if you had like a vintage Les Paul, you could get like 500 grand for it. And today you'd get 100 grand for it. That's still a lot of money, but not if you paid 500 grand for it. So, you know, I don't know, yeah.
I collect box sets of Blu-rays, DVDs, VHS tapes and stuff.
Cool.
To see if they're like be worth more in the future. Like,
Yeah.
I went to Goodwill, got a Rocky VHS box set.
Nice.
$4.
Cool. And so you think because you think like how many people threw out vinyl records at like an alarming rate in the 90s, and now like they go for like $40 each. I used to buy, like I still have most of my vinyl, but you'd go to a shop and you could buy 100 for $5, and now you can buy 5 for $100. It's swapped.
I just saved all my dad's, but like
I love it.
I had like Rolling Stones albums.
Oh, you should bring them in. I don't know if you've seen my turntable, but I got a beautiful turntable in room 80.
Yeah,
You spin. I love it. What do you collect?
Not me, but my dad. He collects a bunch of like toy cars. And they're not toys.
Yeah, but like the die-cast collectibles?
Yeah, and
Cool.
he has, like this yellow Coca-Cola that looks like it's one of the 60s. So,
Cool. Yeah, what do you got?
I got a lot of things. This is one that happens throughout my whole family. We normally collect these special, like silver coins.
Yeah.
Are can be very valuable.
Yeah.
Then my grandmother, she collected comic books, which are from the 80s and 90s.
Yeah.
Then right now, mainly I'm just collecting the most limited edition, kind of like miniature scale models of cars.
I love it. That's awesome. Yeah, and things like that. And listen, as they become rare, people spend money on them. Yeah, you can make money for sure. Yeah.
My papa I have some of my papa's old records, and he has like a whole bunch of Rolling Stones records.
Cool.
And there's like a couple that are like were only sold in England. Cause
Yeah.
I don't remember. And my sister really wants to sell them because they're worth a lot, but my dad has been saying like you have to keep it.
Yeah, I have some records now. I have some records that I've seen sell for thousands of dollars, and that's kind of cool. You're like, hey, I own that. It's in really good shape. If I wanted to tomorrow, I could make $6,000. That's nice.
I wanted Abbey Road, like the Beatles. That's so expensive.
Yeah, if you get a first press of Abbey Road, it's a lot of money. All right, so this is all great because this leads us into what we're talking about, assets. What's an asset? Because all the things we've been talking about, the Abbey Road record you want and the Stones records you do own, and die-cast collectibles and comics, all these things have the potential to be an asset. What's an asset? Yeah, actually, I see a hand there. What do you think? Ooh, that's a really broad view, but it's a good one.
Something you own that's really valuable.
Yeah, very good. That's actually very good. Something you own that has monetary value. So we are using the like.
That's worth money.
Yeah. But we are using like the like financial definition of an asset. Listen, you can be an asset to a company or an asset to your family. Your good nature can be an asset to your personality. But here we're talking money. Something you own that has monetary value, i.e., you could sell it for money. Right? If you own something, and if you turned around and said, I'm going to throw this up on Kijiji, I'm going to throw this up on Facebook Marketplace because I'm 40 years old, or I'm going to put a sign on my front lawn that says, for sale, and somebody's going to buy it. If you could get rid of it and somebody would give you money, then we call that an asset. By the way, if you have money, that is also an asset.
Newspaper.
Say the word slowly.
Sorry?
Say the word slowly.
I think I'm good, but thank you. I appreciate that. So, why do you think some assets increase in value over time? In other words, we're talking about records. And if you bought, the first press of Abbey Road in 1969 when it was released, it was like 34 cents. It was not a lot of money. And then by the 70s and 80s, it probably was worth 20 or 30 bucks. By the year 2000, you couldn't give it away. Literally, you'd go to a Salvation Army and say, here you go, and they'd sell it for $1. And now, boom, all of a sudden they're going for hundreds again. Why do things go up over time?
I think it's because if it's something really old, we may not sell it anymore, so there's a fewer amount of things, and if someone owns it, it's kind of like they have something from a different time period.
So we could say things become rare. I like that.
Hard to find.
Yeah, hard to find. So maybe when it was really easy to find, it was cheap because you could buy it anywhere, but now you really have to look. I like that. Why else might something increase in value over time? That was a good one. I like that.
To become fragile.
Oh, so maybe over time they sure. So how would we say? Because that relates to this, but it could. Sorry. Yeah.
Is it all broken or?
Yeah, I like that.
You have a Model T car that's in mint condition.
Yeah, so which leads back to being rare, right? I'm actually going to draw a little arrow there. Definitely, things that are super fragile and degrade, they can become rare and they get expensive. I like that. What else?
I don't know if this ties into rare, but you know how I'm going to reference Melancholy and Infinite Sadness by Smashing Pumpkins.
Mm-hmm.
So the first CD that they released, the track order was wrong.
It's true.
But in the newer pressings, it was back to normal. So that could also be one of them's unique than the other, or the newer pressings.
Yeah, I'm going to put that in rare too, but for sure. Things like that are always rare. When there's a mispressed album, I have an album that is the front half twice. Literally, it's the front half of the record, and then you flip it over and play it, and it's also the front half of the record. That's really valuable, because it was a mispressing, it was a mistake. Yeah? I like that a lot. Higher demand. Listen, if you start out making a product maybe and you sell it for $20 and all of a sudden this thing is a sensation, it's a hit, everybody wants one.
Fidget spinners.
Yeah. But no, listen, so it's a hit. Are you still going to sell it for $20 if everybody's breaking down your door and they want one? No, you're going to sell it for 40 or 50 or 100 or 1,000. Sure. What a great example! Does anyone remember when people were paying $30 for a thing of hand sanitizer? And you couldn't get toilet paper?
Apparently it's going to be rare again.
Oh, great. Can't wait. What a great answer. Higher demands. Yeah. And then I'll say this too. Has anyone ever talked to a grandparent? I was just talking with my grandpa. My grandpa just moved in with my mom, so we're moving them in. But he was telling us about his first house. And do you know what he bought his first house for?
$100.
Not quite that cheap, but $680.
Wow.
$680. Now, I bought my first house for $103,000. And I sold it a few years later, same house. I'd done a bit of work to it, but not a ton. I sold it a few years later for $250,000. What happened? Now let me ask you, did houses become rare or hard to find? Not any more than they were before. I guess all houses are pretty fragile. Higher demand? Not maybe a bit, but not really. But there's something else. There's a thing that happens with money over time.
Like gets higher and higher, so like the value increase because like you fix stuff.
Yeah. Oh, for sure. Yeah. So we can repair or restore things for sure. So if you make something better, it should get more valuable. Absolutely. That's a really good point. But I was also going to point to a word here that you may or may not know. Have you heard this word before? Inflation. Has anyone heard that before? Sorry, one more time? Yeah, well, it's not the government doing it. It is the market. It is just the nature of things that, listen, because of all this other stuff, over time, everything, literally everything, starts to get a bit more expensive. And then because things start to get a bit more expensive, people need to make more money. So they ask for raises. They get raises. They spend more money. And then because the people at the top asked for more money and got it, eventually people who make minimum wage can't afford it. So they say, hey, we need more money. So the minimum wage goes up. And over time, money gets less valuable and things get more expensive. It's a process called inflation. So that's something to think about. So sometimes people buy things because they go, money gets less valuable, but a house doesn't get less valuable, so it's going to keep rising as money rises. Over time, money becomes less valuable. The buying power of money goes down over time. Which is why, do you know what my first hourly wage was? 1997, I got my first job, and I made a whopping
$6.40?
$6 even. $6 an hour. And like a year after I started my first job, it went up to $6.40. I remember when it went to $6.85. I remember the first time I crossed $10, being like, oh man, I'm making $10 an hour. That's crazy. But you could also go to McDonald's and buy like a Big Mac meal for like $3.50. Things were cheaper. So I made less money, but things were cheaper. Does that make sense? All right. So, things become more valuable as times move on. Not everything, but for the things that do, we have a name for this. And I know it's already written here, but we're all going to write it together because sometimes when we write things, it helps us remember it. Appreciation. Now, can I ask you something? Okay, so, my first house. When I bought my first house, I bought it for $100,000. Over time, it got more valuable, more valuable, more valuable. Because my house was appreciating and getting more valuable, if I went to the bank, did I see money in my bank because my house was worth more? Is that how that works? If something is appreciated in value, what do you have to do if you want to get that money? If you own something, maybe you own a record, maybe you own a house, maybe you own a car, maybe you own a guitar, and you're like, man, this thing has been gaining in value over time. But if you want to see that value, you want to make that money, what do you have to do with it?
Sell it.
You got to sell it, all right? So you have to sell an asset to earn the appreciated money, the money that has grown.
You think people ever just hold on to stuff and then they die?
Listen, yes. Oh man, if you haven't reached that stage in your life, at some point you will, sadly, when people in your life start dying, and it's amazing how much stuff they have. And my advice, sell it and go on vacation. Do your kids a favor. Do your kids a favor. Sell all that stuff that's really valuable and say, hey guys, we're all going to go to out east. We're all going to go to the Nova Scotia and rent a cottage. There you go. I like that. Yeah. Okay, I want you to think now. I want you to just take a couple of minutes and just think. And I'm curious to see your perspective, because Mr. Calford and I, can I tell you a fun fact about us? We're old. Well, we're not old, but we're older. We're not young. Would that be fair? We are thoroughly middle-aged. Or in my case, if my family's lifespan is an indication, a little bit past middle age for the men. So anyway, so I'm curious to see what like a young perspective on this is. So I want you to take, 3 minutes and 41 seconds. And in that 3 minutes and 41 seconds, I want you to make a list of what are some assets, what are some things you could own. You don't have to own them, but you could own. Someone could own. What's a thing you could own that's going to get more valuable over time? All right? Try to think about things. Maybe you're like... Sorry? Ooh, yes, maybe.
No.
Maybe my iPhone 3G.
Yes, an iPhone 3.
I spent a lot of money on that thing. That cost me like $600. That's got to be worth millions now. Everyone wants an iPhone 3G. So write it down. Write it down. They're expensive. They cost you money. They're like kids.
Not so
Are you think you're selling the child? You said that? Okay. All right. Well, we're talking about assets, not appreciate. So unless you're going to sell the child, they can't count as in monetary assets, right? They could be an asset first, and they may have your regular it's all nonsense. But we're talking about cost something like $1.1 million. A lot of money. That's a lot of kids. The number 6. Wow. My mom comes from I'm just going to write a couple, then we're going to move on. But a couple things we haven't talked about yet, new things. Something you're like, well, I haven't heard that yet. Oh, you know what? That's an interesting one. I wouldn't have thought of that. But yeah, gasoline has consistently become more. So if you had a big holding.
If you have shares in gas.
Yeah, and
like a can of gas, don't save it, or it's not going to be good.
Yeah, it will expire. So I'm going to put but gas prices have gone up. So yeah, I'll allow it. Yeah, what are you thinking? Houses for sure. Oh, what did you say? Oh yeah, oh for sure, yeah. Like duplexes, triplexes, everything you can imagine. They are getting more and more expensive, and they will probably only keep getting more and more expensive.
Model cars.
Model cars, I love it. Yep.
Older cars. Yes.
Sure, vintage cars. What else we got? Sure, so I'm gonna put all of that under collect ABLE, ABLES.
Ibble, I think. Apple, I don't know. No, that doesn't look right.
That looks worse. Can somebody give me a quick Google on that? Is it ABLES? I think so. Okay, anything else? So, yep. What? Do we think phones get more valuable? Let me ask you this. My iPhone 3G, it's sitting in a drawer at home. I paid $600 and some for that thing. Could I sell that for $600 and some bucks today? Yeah, I don't think so. That phone is now like, I don't even think it would connect to the network, it's so old. Like,
That's
yeah.
how my tablet was, and it's only like 5 years old.
Yeah, this thing is 12, 13 years old, so I don't think it would do very well. Okay, shh. Listen up. Oh, we have one more? Guys, whoa, I can't even hear myself think. I don't like that. As you know, I love to hear myself. Quiet down.
Especially Tom Allen over there.
Yeah, keep it down. Thank you. What's that? Oh, yeah, that's very good.
There's a big one. Gold, diamonds,
Yeah. Yeah, no, absolutely. All right, listen. Shh. If you want to know how much an investment is appreciated by, it's actually a simple calculation. If you want to know how much something has gone up by, what kind of math are we doing? Am I going to be multiplying? Is this going to be exponents? If I want to know how something has changed, what kind of math do I do? I'll tell you like what's going in here. We want to say the appreciation, and basically it would be like the original value. Actually, I don't like that order. The final value and the original value. What would I do with those two? How would I calculate that? Let's say Mr. Calford bought me a commemorative keychain that said world's most adequate teacher. And he bought it for $10. And now I went and I sold it for $30. How much did it appreciate? How much money did I make with my world's most adequate teacher keychain? Good, how'd you do that? Good. So what operation goes in here? Almost. You're adding to get there. But with these two numbers, 30 plus 10 wouldn't be 20, it'd be 40. What sign has to be here? Yeah, very good. Subtraction. So if you want to know how much something is appreciated by, you take the final value and you subtract what it was originally worth. And if you want to do that as a percent, you do the same math. You do final minus original. But then you divide it by the original. That'll tell you what percentage you've appreciated. And then you have to multiply it by 100% because otherwise it'll be a decimal, and we don't like decimals. I like decimals, but
I don't think we need percent on it. Just the 100. Because it is the percent. That's all good.
So the dimensional analyst in me says you need a unit there, but that's fine. I will.
Because it's not really a unit. Because the percent means okay.
I don't think it makes, I don't think it makes an ounce of difference. So these are the calculations. So let's try that. Robert bought a house in 2006, and he bought it for $130,000. He sold it in 2021 for $530,000. Oh my goodness, that's a lot of money. Did he make money? Yeah, he did pretty good. So what we want to know is, what was the appreciation and what was the percent appreciation? How much money did he make and what percentage is that? Did he get 10% extra, 100, 200, 5,000%? So your equations are there. Take 2 minutes and sort them out. We'll come around and look and say, hey, good job.
Both shots. You have to do it because it's a public institution.
Sorry? Wait. Alex, wait, Max? I can have you do that. Oh, not that. Oh. Yeah, so you have to think by eye, which is great. Which is totally good. When you get to that, you can't do that. I love that you can do it in the head. If you subtract, it will do the same thing. You're totally right. Right? If we do 530,000.
Alex, there doesn't Alex they get 400,000. Good job. Get on it, team.
What if I was just so annoying?
No, I was dying.
Alright, try it.
That's my Let that sink in. See the expression is the yeah, you're just a shy percent. You're just a shy percent. You look like perfect. That means like 100% of it would have been making $130,000. Good. Good.
You made this.
So, show me this one again, because I love that, and I like that, and multiply it by 100. Is that 30? Is that good? Should be 30%. 40 divided by 400 divided by 100. Love it. Look at that. We multiply that by 100, we get 307%. Big increase. Which makes sense, because 100% would be if you doubled his money, right? 200% would be, just you know, got it again, 300 again. So that's a good return on investment. Yeah.
Oh, 7.
Well, I'll tell you, if you got 6, you won the game. I would have got it. She didn't less. She didn't have skill. I don't know you guys. How are you guys doing? Like, what the law? It's so that it's so expensive. So if you already own, that's amazing. You have this asset and pay a ton of money. If you don't own the asset, so it's
Christian, did you make that?
Oh,
You can take this number out, then you log
Whatever this one is.
It's from her.
No, I just love stealing them.
all right, let's take a look here, shall we? Okay. So if we want to know how much it appreciated, can someone remind me, what's that word mean? This says appreciated, which means it's increased in value. What was its final value? For this house, what was it worth at the end? Worth when he sold it? Yep. He sold it for $530,000. That's a lot of money. That is probably more money than you have in your wallet right now. That's more money than I have in my wallet right now, for sure. What was the original value? What did he pay for it? What's the original value? What did we pay for this house? Yeah. 130,000. Did Robert do well here? Yeah, Robert made some money. And what do we do between them to find appreciation? Subtract. And so the appreciation is how much in this case? Yeah, he made 400,000 bucks. That's pretty good. Now, sometimes we want to know, as a percent, how did I do? Does that make sense? You know, what percentage did I make on my money? This is a lot because he actually made way more money than he put in the first place. He made a lot of money. How do we figure it out as percentage? Well, we do final minus original, and then we divide it by the original again. So to get the percent appreciation, we do that 530,000 minus 130,000, which we already know is 400,000, divided by 130,000, and then to make it a percent means per out of, cent is French for 100, it's also Latin for 100, which is actually where this comes from, but that's okay. And so we can do that in our calculator. In fact, I'm going to do that in my calculator. So we did 530,000 minus 130,000. That's fascinating. What did I do wrong there?
You're supposed to do the...
There we go. And then I need that 400,000, and I need to divide that by what? 130,000, right? And it gives me a number 3.07. What do I have to do with that now? Times it by 100. I bet it is. And what percentage did he make? What percentage did he make? That's a good percentage. That rounds to 308%. If you can buy something and have it appreciate by 308%, you've made a good investment. I'm trying to think, have I ever had something appreciate by 308%? I don't think so. Maybe no, my house isn't there yet. It'll probably get there. But then again, I haven't owned my house for 15 years, so maybe when I have. Does anyone have any questions about that? What that means, how we did it? And let me ask you on a side note, have you ever kind of done math with money like this before, or is this new? Like thinking about savings and thinking about things growing. Kind of new? Yeah. Have you? Yeah, a lot of times the way we learn this is from our parents or from our aunts and uncles. My grandfather was an accountant. That's where I learned this stuff. But it's new in school. Mr. Calford and I have never taught this to grade 9s before. I think it's really nice that we're learning it at this age. It's important stuff. Okay. I want you to look at this graph. And I think we're going to aim to get through one of these today, and then we're going to jump to the other two tomorrow. But one will get us there. This relates to two ways of making money. And you don't have to worry about these too much, but one of them is called compound interest. That's the one here in orange. And one of them is called simple interest. So if you are saving money or if you're depositing money, these are two ways that you could earn money back. And I want you to look at the graph and just tell me what you think the difference between the compound interest done in the orange and the simple interest done in the blue is. What's the same about them and what's different? And then see if you can answer the questions below. Don't answer them out loud. I want you to try it on the page. Yeah. Cool. Yeah, they went together, and then boom, they break apart. Yeah, that looks great. All right, so really quickly, what's the same about these graphs and what's different? So this is us earning interest, either simple or compound. What's the same? Yeah. So we start, and I love that y-intercept. They start at the same y-intercept, which is what? Yeah, so this starts as $10,000, presumably in the bank, saved. Cool. What else is the same? They start at the same spot. Oh, very good. Yeah, they're going up. They're both going up. That's, I think, a really important point to note. Whether you're getting simple interest or compound interest, the amount in your account is going up. That's a good thing. We like when our accounts go up. Is there anything else that we notice is the same about them, or we jump into differences now? What's something that's different about them? How are they different? Yeah. So compound goes up more. The less common spelling of goes with a U in the middle. Okay, I like that. That's very true. What else can you tell me? That is definitely true. Yeah, Ashley. Oh, I like that. Look at you. I'm not even going to say which is which yet, because you're going to tell me that. But yeah, I like that. That's good. Anything else? All right, then what I want you to do is I want you to take just 2 minutes here. Based on this graph, do you think the simple interest, the blue one, is that linear or nonlinear? Do you think the orange one, is that linear or nonlinear? And then just see if you can answer the rest of these. All right, just take 2.5 minutes with it. Why, hello. It's just like musical chairs. Does it not? Like, it's attic. I was going down. It's like you're in the age voice.
Linear and non-linear relationship. And then the answer to the question is
oh, which is which? Yes, of course. We're like how desperate are you?
like really desperate.
Yep, okay, I don't want to that. Okay, look up here, talk to me. Shh. This blue line, just looking at it, and I mean it's hard to see, but do you think that's linear or nonlinear? And how would you check? If you want to know if something was a straight line, what would be a good way to check? Yeah, I could take a ruler and double check, because to me it definitely looks linear, and I line this up, and yeah, I mean, I'm not doing a great job here, but I would say that's pretty darn linear. So I would say that our simple interest is a linear relationship. What about the orange one? Would you call that linear or nonlinear? You think nonlinear. And again, if we weren't sure, if we wanted to check, what could we do? Yeah, and if you look, if I get the ruler sitting nicely here, does it sit nicely there? And if I get the ruler sitting nicely here, it's not good there or there. If I get the ruler sitting nicely here, it's wrong everywhere else. It rolls along like that. So, we'd have to look at that and say, nonlinear, because it curves. Hey, for the simple one, for this one here, could you get to year 15? What do you think? Because we know straight line rules. We know what we can keep doing with a straight line. So,
how much money does it go up by every year?
Yeah, what is it going up by every step?
The rate of change.
Like we're going from 17,500 to 19,000, 19,000 to 20,500, 20,500 to 22. What's it going up by each time? How much?
1,500.
Very good. It's going up by 1,500. And so, if we know that, could you figure out what 5 more years will look like? I bet you could. I mean, there's lots of ways to do that. You could just go 1 more year, this would be 26,500.
You guys know how to make an equation from a line, don't you? You can do that.
Yeah, but that's exactly it. Where does this start? Because we could say the value started at, we know it's going up by 1,500 over and over again. And what did it start at? 10. So that's a perfect example of an equation. Right? That's what a great place to make an equation. The value is 1,500, however many years we go on, starting at 10,000. Plug that into your calculator for 20 years, or 15 years rather, and you'd be good to go. You could just say, value equals, we went up by $1,500 15 times, and we started at 10,000. Did anyone do that? What did we get at value at 15 years? Yeah.
32,500.
How much?
32,500.
32,500. That looks good to me. That I haven't plugged that into a calculator, but that seems to pass my sniff test. Did anyone get anything different, or we like that? And which one of these would you rather, if you're making money, if you're putting money in the bank and they're going to give you simple interest or compound interest, just looking at this graph, which one would you want? Yeah, definitely. You know, in the interest of full disclosure, I didn't make this lesson, and when they first presented it this way, I kind of thought, this is it's weird how early we're hitting those terms, but I think I actually really like it. Yeah, just looking at this visually, there's 2 kinds of interest you can be earning. We'll teach you later how they are calculated, but for now, one of them is going to make you a lot more money. By the way, if you're borrowing money that you're going to have to pay back, which one would you rather they calculate it based on? Well, I see people putting things away, but we got lots of time. We're here till 10 after. Take those back out. Bell to bell, team. You know my rule. Okay, so here's what we're going to do. The homework is going to end up getting split between 2 days, which is totally fine. So look here. We will finish up this lesson tomorrow, though really we've done all the hardest work. Can I show you all something? Look here. There's 2 things I want to note on the second page. The first is, I couldn't decide which question I wanted to go with here, and then I accidentally left them both in. That doesn't work. So I'd like you to cross that off. right away, because it's not the same number as the other one. So let's all do that. Let's make sure we're all looking there. B, scientific notation. We're just going to cross that off and replace it with the right answer. Real dark. And then I want you to listen. Look here. I want you to know that this question is tricky. I think you can do it, but it is definitely it's an extension. It's using scientific notation, but you also have to square a number. This is a tricky one to put into your calculator. I'll be very impressed if you get it. Now, on your way out, I would like you to deposit your calculators where they go.
You'll notice two metal charging prongs, and you'll notice prongs inside the slider. They don't go this way. They won't charge. There's a way that they go, and it clicks nicely. So
but I want you to know something else. Look here. What does this say? So what number should go right here? 31, then 32, then 33, all the way up to race. What numbers go in this one? So what should go in the first slot? What number should go in the last slot? Good. And make sure it's charging. Make sure the prongs go on the charger. What goes in this one? Okay. This one is not 5160, which is right here. And then if you have from this one that I still have the label, I need to change my label. If you've got an oddball, go in this one. So make sure it goes. Amazing. Thank you. I would say this class effectively does this.